This is Geometry, Unit 9, Classifying Quadrilateral Worksheet. This is from Day 7. So, talking about our midpoint formula, typically we say x1 plus x2 over 2, comma y1 plus y2 over 2. The distance formula, x2 minus x1, quantity squared, plus y2 minus y1, quantity squared. Then a slope formula, y2 minus y1 over x2 minus x1. Those formulas, you need to know those by heart. You need to be very familiar with which ones have the minus, which ones have the plus. All the little details about those formulas are spots that people have struggled with. We're supposed to state the most specific name for each figure. We notice here that we have two sets of parallel sides. We don't know about any right angles. We only can tell that this is definitely a four-sided figure, which is a quadrilateral, but because of the parallel sides, two sets of them, we know that this is a parallelogram. Here we have one set of parallel sides. The other set is not parallel, so this is a trapezoid. There's no indication that the other two legs are the same length. They would have to be slanting at opposite slopes, and you can tell this is much more vertical, which this is just a positive slope. Here we know opposite sides are congruent, so we know it's a type of parallelogram. Plus we have the right angles. We know that all the sides are not the same, so this is just a rectangle. Number 4, we have four sides. If you would look here, another way we could have this marked is that all the sides are different. So there's nothing special here. A kite would require two sets of consecutive sides to be the same. We don't have that anywhere. So this is just a quadrilateral. This last one, we have four sides that are all the same shape. Since it has two sets of opposite sides congruent, we know that it's a parallelogram. But we also know, because the consecutive sides are also congruent, that this is a rhombus. We'll come down and we will plot our points. 2 over 1 up, 6 over 1 up, 3 over 8 up, and 5 over 8 up. So we have P, S, R, and Q. So the points P, Q, R, and S are the vertices of a quadrilateral, give the most specific name. So we want to show what needs to be done to identify what shape it is. You should be able to look at it and start to predict what you think it is. Then you need to show the evidence that supports what your thinking is. I'm looking at this and I'm predicting that we have some parallel sides. These don't look parallel to me, so I'm predicting that those might in fact be congruent to each other. So let's find out what happens when we start to do some of the work. PQ. The length of PQ, because it's horizontal, we can count that, and that's 1, 2, 3, 4. So PQ has a length of 4. QR is slanted, so we can't count that amount. We have to do our distance formula. So QR, we'll take the x value minus the x value and the y value minus the y value. So that leaves us with 1 squared and negative 7 squared. So that's going to come out to be 1 plus 49, which is the square root of 50. RS, again, that's horizontal, so we can count that. That's 2. But PS is slanted, so we can't count that. We have to do our calculation. So P, take your x value, which is 2 minus 3 squared, and 1 minus 8 squared. Negative 1 squared, negative 7 squared. 1 plus 49, that's also the square root of 50. So because we have two sides the same, we do know we have a pair of legs the same length. Next we're going to look at slopes. We're going to look at the slope of PQ. So to figure out PQ, we come over here to our coordinates, and the slope, we take our y values. y2 minus y1, x2 minus x1, that's 0 over negative 4, which is 0. We predicted that just because it's a horizontal line. We know it has a slope of 0. QR. For QR, we say 8 minus 1, 5 minus 6 becomes negative 7 over 1. Positive 7 there, but negative 1 on bottom. We typically just put the negative in front. RS, 8 minus 8, 5 minus 3, 0 over 2, that's 0. So here we have the same so we know that the same slope is going to make them parallel. Then SP, 8 minus 1, 3 minus 2, 7 over 1, that's 7. Notice that 7 and negative 7 are clearly opposites, but they're not reciprocals. So those two slopes are not the same. So we have one set of parallel sides with the different set that are congruent to each other. So this shape is an isosceles because two sides were the same. Trapezoid, because we have exactly one set of parallel sides. One pair of parallel sides, one pair of congruent sides. The parallel sides are called the base, and the congruent sides are called the legs. On the back side, we'll plot our points. So we'll look for P to be at 2, 7. Q to be at 6, 9. 5, 1, and 9, 3. So again, I look at this one, and we're going to find some distance values and some slopes. So we'll first look at PQ. So we do our distance formula, which is x2 minus x1, y2 minus y1. So P is 2 and 7. Q is 6 and 9. So for the x's, we did 6 minus 2 and 9 minus 7. Notice how we go to different points. So 4 squared and 2 squared. So we get the square root 16 plus 4, which is 20. No need to worry about a decimal with that. You could simplify that if you wish, but we're just comparing, so square root of 20 is fine. QR, we've got 9 minus 6 and 3 minus 9. For the Q and the R, we do the X minus the X and the Y minus the Y. 3 squared plus the negative 6 squared. Notice how I put parentheses around the negative. Otherwise, when you square the negative 6, you would not get a positive 36. So here we have different side lengths. These are consecutive sides, and we're getting different side lengths. RS is an opposite to the PQ. So you might have a prediction of what you think with that. 9 minus 5 and 3 minus 1. So R, 9 minus 5 and 3 minus 1, gives us 4 squared and 2 squared, which is 16 plus 4, which is the square root of 20. PS. So here we have, let's see, I actually wrote the y's first. It'll be fine for the calculation. 2 minus 5 and 7 minus 1. That would be x's and then y's. Negative 3 squared and 6 squared. That's 9 plus 36, which gives us 45. 45. So these are the same. And these are the same. So what that means, we have opposite sides that are congruent to each other. So we know that that's one type of parallelogram. We're going to look at slopes. So PQ is 9 minus 7 and 6 minus 2. That comes out to be 2/4, which is 1/2. QR, 9 minus 3, 6 minus 9. That reduces down to negative 2. RS. You look at your R and the S. First you do your Y values, 3 minus 1. Then you do your X values, 9 minus 5. That's 1/2, which is matching the other slope. The slope of PQ. PS, 7 minus 1 and 2 minus 5. 6 over -3, which again is -2. So we have these two slopes that are the same, and we have these two slopes that are the same. Notice that one is positive and one is negative. So they're opposites. One is 2, which is like 2 over 1, and one is 1 over 2. So they are perpendicular because they're opposite reciprocals. We have two sets of parallel sides. We have a 1/2 that match and -2 that match. We have opposite reciprocals. So we know that we have right angles. And we have two sets of opposite sides congruent. So that helps rule out that this is not a square. All the sides weren't the same. So this is a rectangle. Okay, last question. For number 8, plotted out the points, started to look at their distance of PQ, P to Q, so we say x2 minus x1, y2 minus y1. That's the square root of 16 plus 1. This has the square root of 17. QR, 5 minus 6, 8 minus 2. RS, 2 minus 6, 1 minus 2. Gives us the square root of 17. And then for our final distance, PS, 2 minus 1, 1 minus 7. Gives us the square root of 37. So again, we have two sets. Those are the same. These are the same. Now to look at the slopes. PQ. We do our y values, y minus 7, and then our x values, 5 minus 1. Reduces to 1/4. QR, 8 minus 2, 5 minus 6. That reduces to 6 over negative 1, which is negative 6. RS reduces to 1/4. And then PS reduces to 6 over negative 1, which is negative 6. So again, we have two sets. That's the same. That's the same. But if you notice the slopes themselves, they are not opposite reciprocals. They're opposites, but they're not reciprocals of each other. 6 and then the 1/4, not reciprocals. So what shape do we have? We know we have two sets of parallel sides. They're two sets of parallel and congruent sides, but that's all we've got. So we know that this is a parallelogram. It's not a rectangle because it doesn't have opposite reciprocal slopes. It's not a rhombus because we don't have consecutive sides congruent. It's not a square because it's not a rectangle or a rhombus. So that just leaves us with the basic parallelogram.